All right, so for this video, I'm going to go over the conceptual questions that are going to possibly be on the exam. There's only so many that can be on there, and I'm not going to be able to do the ones that are about the systems and whether or not the systems work with what we're given or not. Instead, I'm going to be doing the ones that are about tautologies and consistencies and contingencies and how we can figure out whether or not an argument is valid or invalid depending on what we know about the premise and the conclusion. So let's start with how we can tell if A, therefore B, is valid or invalid depending on what it is that we know. Again, apologies for the background noise. I didn't have a choice, but I'm in a public space and people are arguing about things that they actually have no idea about. Problems of being a philosophy major, there's bad arguments everywhere. So let's start with what happens if we know that A is a tautology and we know that B is a tautology. We can diagram everything in this fashion. A, therefore B, and we can ask, what would that mean if we did like a truth table? At any point for these lines, would we find that we have a T premise and a false conclusion? Well, if A is a tautology, its T's all the way down. If B is a tautology, its T's all the way down. Is it possible to have T, therefore F? No. Therefore, the argument is valid. So let's ask what would happen if we knew instead that A was an inconsistency and that B was a tautology. Let's do the same thing. A, therefore B. If B is a tautology, its T's all the way down. If A is an inconsistency, it's false all the way down. Are we ever going to have T, ergo F? No. So, it's valid. Let's go to the next one. Let's say that we had, again, A, let's make it an inconsistency. And let's make B an inconsistency as well. A, ergo B, is going to look as follows. A will be F's all the way down. B will be F's all the way down. Are we ever going to find a T, ergo F? No. Therefore, again, this is valid. So let's figure out what would happen if instead we had A is contingent and that B is contingent. If it's A, ergo B, what do we know about the truth table? The truth table would look as follows. A would have at least one T and at least one F somewhere. B would have at least one T and at least one F somewhere. So could we ever have a T, therefore F? Maybe. It's actually unclear. Because since A is a contingency and B is a contingency, it could be that we have a truth table that looks like this. This is a possibility, but we don't have T, therefore F. We could also have one that looks like this, though. In which case we would have T and an F. But we actually don't know between these two options which one would be actualized. So the answer here is can't tell. So let's think about what would happen in this case instead. Let's say that we had A is contingent and B is a tautology. Let's draw a truth table. So for B, that means it's a T all the way down. In A, we have at least one T somewhere and at least one F somewhere. We don't know how many other things we might have, but do we ever have T, ergo F? No. If the conclusion is always true, we can't ever have an F. So this is valid. Okay, so let's keep going. Let's say that we knew that A is contingent and B is inconsistent. A, ergo B, is going to look as follows. We have A, therefore B. We know that B is inconsistent, so it's F's all the way down. And A is contingent. So we have at least one T and we have at least one F. Will we ever have a T, ergo F? Yes. We are guaranteed to have at least one T and one F, given that the conclusion is always false, and in being contingent, there will be at least one T in the A column. So this argument is invalid. So let's say that we knew that A was a tautology and that B was inconsistent. If A was a tautology and B was inconsistent, this is what we would have. A is T's all the way down, B is F's all the way down. Will we ever have T, therefore F? Yes. Actually, this is all T's and F's all the way down. So this is very much invalid. How about if we had A is inconsistent and B is a tautology? We draw our truth table. B is T's all the way down. A is T, at least, nope, A is F's all the way down. Will we ever have T ergo F? No. If the conclusion is always true, then there's never going to be a space in which we could have T therefore F. And if the premises are always false, again, we're never going to have a T arrow F because there is no T. So this is definitely valid. Let's do two more. So let's say that we had A as a tautology and B as contingent. It would look like this. A ergo B. A is T's all the way down. B is sometimes T and sometimes F. Will we ever have T ergo F? Yes. There's at least one instance in which the conclusion must be false, and if the conclusion or if the premises are always true, then we're going to be guaranteed at least one instance where we have a row where the premises are all true and the conclusion is false. So this is invalid. Last but not least, let's say that we had A is inconsistent and B is contingent. Our truth table would look like this. F's all the way down, at least one T, at least one F, we don't know how many. Will we ever have T ergo F? No. Why? Because we always have a false premise. If we always have a false premise, it doesn't matter what the value of the conclusion is. We could never have all true premises and a false conclusion. So this argument is valid.